Hello everyone. So in this video we will discuss um, how to write the program to compute DFT for the following sequence. So in your exam may you will get this program, okay? So they will ask to write the program to compute the DFT using a equation. Okay, so you shouldn't use inbuilt DFT function, that is FFT, in order to compute the DFT for the given sequence. Okay, so you have to write the program for the DFT using the equation. You know what is the DFT and all? Okay, so discrete Fourier transform. Okay, you know very well what is the equation, right? um, so this is your equation, right? So endpoint DFT equation. Okay. Where is the pen? Okay, see here. So DFT means discrete Fourier transform. This is the discrete time sequence with length L. Here the L is, the capital L is the length of the discrete time sequence. X of k is the DFT of x of n. So how we will get this x of k, right? So you know very well this is the equation, right, in order to compute the DFT for the given x of n sequence, right? Summation n is equal to 0 to n minus 1. N is the endpoint DFT. Okay, endpoint DFT. Okay, so n is where small n is the discrete time sequence, right? So the n value is varies between 0 to n minus 1. Okay, so x of n e to the power of minus j2 pi by n into kn. Here the k and n values varies between 0 to capital N minus 1. Okay, so here this condition should be satisfied. So if it is not satisfied means aliasing effect will exist. So in order to avoid aliasing effect, so n should be greater than equal to L. Okay, n should be greater than equal to L. N is the endpoint DFT, L is the sequence of length of this x of n sequence, length of the x of n sequence. Okay, so usually the x of k value should be complex number, right? So that k values varies between 0 to n minus 1. Okay, so and another point is here, so they will also ask to find out the magnitude and phase spectrum of DFT. Okay, so you know the very well the equation to find out the magnitude, right? So the magnitude of x of k is equal to real part of x of k square and imaginary part of x of k square, right? So similarly the phase spectrum, this is the mathematical representation to find out the magnitude spectrum. This is the phase spectrum. So phase angle of x of k tan inverse imaginary part of x of k divided by real part of x of k. So these two equations are very important to solve the problem. Okay, so in the Matlab we are going to use inbuilt functions in order to find out magnitude spectrum and phase spectrum. So these two spectrum we will generally call as a frequency spectrum. In the frequency spectrum we will get the two spectrum, one is magnitude spectrum and phase spectrum. So let's we start how to compute the DFT. So using the Matlab program, right? So here we are not going to use inbuilt function, we are going to use a DFT equation to solve the problem, DFT problem, okay, or to compute DFT, okay. So you know very well, right? Just I will increase the font size. Mm, Or B is that I am able to see zoom. Okay, just I will increase the just I have magnified my screen. Okay, so you know very well CLC means what? Clear command. What is the CLC? Clear command. So we will clear this command window. Okay, so this is the command window, right? So this is an editor window, you know very well. This is the current folder, what all the folder so we have opened previously. What is the current folder? We can see in this. Okay, and another one is workspace, right? So what are the variables we have used in the program? So those variables we can able to see in the workspace, right? You know very well all those things. Okay, CLC is a clear command. Clear all means it will clear all the variables whatever we have used previously in the workspace. Close all means it will close all the whatever window we have opened while executing the programs. For example, if it may be a figure, so figure window, it will close all the windows. I mean that figure windows. Okay. So this is the display means it will display this statement in the command window. So disp. So we have to write within the single quote whatever we need to display in the command window, we have to write within the single quote, right? This is the program to compute DFT using formula. Here we are using the equation to compute the DFT. F print f, what is this? So in order to start from the new line, so we have to use this f print f, right? So backward slash n, you have to return that one within the single quote, right? It won't continue from this statement. Okay, at the end of this statement it will start a new line if you are using this f print f, right? So the next one is, so from here onwards our program starts, right? So getting the input sequence, here we have to use input function. It is an inbuilt function, right? So we have to write the enter the sequence within the single quote. This is the x is the variable. Here in this variable we are storing our all the sequence, right? So here, so we are determining the length of x. So we don't know. So might be we will give sometime four values, right? Or four samples. So sometime we'll give 8 values, right? So first we need to find out the length of x, right? So after that we have to enter the, so at how many points we need to find out DFT, right? It is an 8-point DFT or 4-point DFT. So based on that, we have to change this our input sequence length. We will see what we will do. Okay. So here, in order to avoid aliasing effect, we know very well n should be the capital N, right? Endpoint DFT should be greater than length of input sequence of x, right? So here for example our input sequence is 4.4, right? Which means the input sequence length is 4, but we need to calculate the 8-point DFT. That is, if the n value is 8 means, so the remaining 4, so we should have to append zeros at the end of x, right? So I think you have understood what I'm going to say, right? See here. So our capital L is 4 point, for example, right? The length of the input sequence is 4, right? For example, x of n, it is a small x, okay? N is equal to 1, 2. This is 4. The length of the input sequence is 4. But I have to compute the endpoint is, capital N point is 8. So that time, so n should be greater than equal to n. This condition should have to satisfy. Okay. So here, so I have to append, see here, n minus n, right? That is, here n is equal to 8. Our input sequence is L is equal to 4, right? So minus 4. 8 minus 4 is 4. We have to append 4 zeros at the end of input sequence. Okay. 1, 2, 3, 4. So I have to append 4 zeros at the end of our input sequence. Okay, this is the concept. Okay, so even in your your exam, in your it may be an CAT exam or your main exam, maybe you will get a question like this: compute the DFT, right, using appending zeros, right? So this problem is also there. Okay, you can also see that problem in your Ramesh Babu book. Okay, we will continue, right? Um, so if this is a if loop, okay, so if, and it should, we have to write end. If you are starting, if you are using if means, so it should have to be, you have to write the end, right? This is the syntax, if syntax, if and within this, within the within this, the body of the if, we should have to write this one. This is the body of the if and end, right? So if condition is n should be greater than length of x, right? And greater than, if it is n is, if this condition is satisfied means, so we have to append zeros at the end of input sequence of x. This is our input sequence of x. So this is very very important, this function, right? So this is zeros. This is an inbuilt function. Zeros of one row, right? N minus length of x. I have written that n minus l, right? So one row, there is, we are adding 4 zeros, 1 comma 4, right? One row, 4 columns, like that. So here, as it is a matrix, so everything it will take as a matrix. Okay, so 1 comma 4, so it will add 4 zeros at the end of input sequence of x. After appending zeros at the end of input sequence of x, so I here, so I have given disp of x. Just I want to see how it was appended, right? So I have given disp x. No need to write this one. So for my curiosity, I have written this disp of x. Okay, so after that, so here we need to compute DFT. This is the um, important part. Okay, so you have to write the code very carefully. Here we are using the for loop. Here we are using two for loops. Here also we have to use two and, right? Right, as same as if function we have used, right? Similarly, so we have to use for loop here. So because we have k and n value, the k and n value, both values are varies between 0 to n minus 1. Here I have taken k value 1 colon 1 colon n, which means if it start from 1, the step function is 1 and ends with the endpoint value, right? So here I have taken the temp variable as a variable, so I am storing 0 value in the temp variable. Okay, so this is another for loop. N is equal to the n value, small n value is varies between 1 to n with the step function 1, right? So here, so you know already the equation of x of k, right? X of k is equal to summation n is equal to 0 to n minus 1 x of n e to the power exponential. Here exponential, here we are not using any e, so here e means exponential of minus j 2 pi pi is the pi value, right? Pi 2 pi by n into, actually in the equation we are using k and n. Here we are using n, instead of n, here we are using n minus 1 and k minus 1, because here we have taken the value, here we are now taken the value 0, here we have taken the value 1 in for both k and n, right? So here it is not started from 0, so it is started from 1. So that's why here we have taken n minus 1 and k minus 1, right? The initial value is x of 0, right? Here, so it will, if we are using this 1, k and k is 1 and n is equal to 1 means, so here the value is 0 and 0, right? So first it will compute this for loop, right? First it will take k value is 1, just I will show for only one value, right? Just I will discuss that one. So for first, the for in the for loop, the k value is 1, right? So initially the temporary value is 0. Thereafter the small n value is 1. Here the temp value in both the, this is the final result, temp value 0, here is also 0. Here the x of 1 value, first it will take x of 1 value. For example, it is 1 means it will take x of 1 value as a 1, exponential of minus j 2 pi by, for example, if we are calculating n point is 8 means divided by 8. Here n value is 1, 1 minus 1 means 0, k 1 minus 1 means 0, right? Here our 0 value is 0 only, right? Here there is no value 0, right? N minus 1 means 0, means the whole, the exponential function, it becomes 0. E to the power of 0 means 1, right? Here x of n value is 1 means 1. Initially the temporary value is 0, right? So here it will store temp value is 1. Here the temp value no more, it becomes 0, now it becomes 1. Again it will calculate up to n is equal to 8, right? Now here, now n value is 2. Until it completes 8, the for loop it will rotates here, right? It will always, it will update this temp value, right? When it will ends, so once if it is n value is 8, it will ends, then temporary whatever the final value stores in the temp, it will stored in the x of 1, right? X underscore DFT 1, it will stores the final value. Again it will verify whether k is 8 or not. If it is not 8, again it will increase the k value as a 2. The cycle will repeat. Okay, once if it, once all the k values are computed, once if it is every values are computed, okay, so we have to display those value as a spectrum, frequency spectrum, right? So here we need to calculate magnitude and phase spectrum. Here we are using the inbuilt function, right? So here first I am displaying the x of k value, right? DFT of x of n I am displaying. Thereafter I am computing the magnitude value and phase value. Here the inbuilt function in order to calculate magnitude absolute. So here just you have to use absolute function in order to calculate magnitude of x of k, absolute of x underscore DFT. So thereafter, so I am displaying that values and I have to find out the phase angle of x of k. Here I am using angle. Angle is a inbuilt function, angle of x underscore DFT, right? So I am storing those values in this variable phase underscore x underscore DFT, right? So thereafter I have to display as a figure, right? So this is figure 1, right? In the figure 1, so first I am taking the I have to display the input sequence. So for example, so if it is input sequence 4, so I have to take the length of x, right? So this is x, right, of 1 colon, it start from 1 and length of x. So I'm storing in the x underscore origin variable, right? So after that I am placing the placing all three figures. What are all the figures? One is the in input sequence, right? So DFT sequence, right, and magnitude spectrum, phase spectrum. No need to display input sequence, just you can display the x of k value as a figure, magnitude spectrum and phase spectrum, right? So here I have taken 3 rows, right, 1 column. So this is up to you, whatever you wish you can use. How to place your figures, it is up to you. This is I am using general case. This is a 3 rows 1 column, right? 3 rows 1 column. I am placing the first figure in the first row, right? See here, so this is the variable ax. So here the n value varies between, right, 0 to n minus 1 or the length of x, because here I am displaying the input sequence. So based on whatever, if it is sequence is 4 and the length of x is 4, means it should have to display for only 4 values. It shouldn't display for appended 0, right? Be careful with that. So 0 with the step function 1 and length of x minus 1, right? So this is x original. Here we have already stored the original length of input sequence in the x underscore origin, right? So stem, this is the x. Stem means we have to display as a discrete. So we shouldn't need in the I have discussed all those things in detail in our previous videos, right? So stem is used to display in the as a discrete. So if you are using plot means it will display as a continuous. I have discussed in detail about what is continuous, what is discrete, right? Please see my previous videos in order to understand all those things, right? So now I am going to display the discrete sequence or discrete input sequence, right? Stem, this is the x value ax. This is ax value is varies between 0 to length of x minus 1. This is the x origin. X origin means this is the magnitude or amplitude of input sequence, right? So this is x label function in order to display these samples as a label. Y label function is used to display this amplitude in the as a label in the y axis, right? Title, so here this is the input sequence. Title of the first figure is input sequence of x of n. The second plot is displaying the magnitude, right? So magnitude of the x of k, right? So in the second row, so I am displaying the magnitude of x of k, right? So here I am taking the x-axis, so I have to have to from which value it should have to display, we have to give this one, right? So in the stem function we have to assign the both x and y value. This is an x value, so it varies between 0 to n minus 1, right? This is the magnitude, right? We have already calculated using absolute function. That variable we have used here as a y function. Similarly, these things are similar. This is the k value, right? So the k value is very pretty, 0 to n minus 1. This is the y axis, right? This is the magnitude of x of k. This is the title, DFT of magnitude response. Similarly, subplot 3, 1, 3. This is the third row. In the third row, it displays the magnitude of, phase of x of k, right? This is the x-axis. Values varies between 0 to n minus 1. So stem of AP, this is the variable we have used the angle of now to determine the phase spectrum, right? So in this we will get the angle of x of k, right? X label is as same as this is the k, and y label is angle. Title is phase response of DFT. That's all. Just I will execute and I will show you, right, how we will whether this code is correct or not. I have already solved one problem, so just by using that problem I will verify whether the given code is correct or not, whether it will display the correct result or not. Okay, just I will run. So after running, so this is the program for DISP. We have written as a DISP, right? This is the program to compute DFT using formula. So we have to enter the sequence. Just I will enter 1 by 3, 1 by 3, 1 by 3. Okay, this is the input sequence length is 3. Okay, so just I need to calculate, it is a 4-point DFT, right? I will enter 4. See, this is DFT sequence, right? DFT of x of n, right? This is the magnitude, this is the phase angle, this is the DFT of input sequence. Just I will verify with my result. Okay, see here. Here I have taken this problem. I have given 3 values because for n value 0, 1, 2, the amplitude is 1 by 3. The remaining value of the remaining value of n, that is above 3, right? So the value is, the amplitude of x of n is 0. That's why I have given only 3 values. So I have to compute 4-point DFT, right? Just I will verify whether I got correct answer or not. See here. So this is my magnitude values. This is the phase values, phase angle values. See here. See here. This one, magnitude of x of k, 1, 0 0.33, 0 0.33, 0 0.33. See here, 1, 0 0.33, 0 0.33, 0. So now we will verify whether we got correct phase angle values or not. Okay. See here, minus 0, minus 0 0.55, 0, 0 point. Here pi means 3.14. Just multiplied 0.5 with 3.14, you will get, just you will verify with the calculator, you will get minus 1.5708, 1.5708. So we got the same values whatever we computed, right? The same value only we got in the Matlab program. So right, so here we have written the Matlab code for the DFT using a equation. So we have computed DFT using the mathematical equation of DFT, right? So we got the same answer. So whatever we have written, that code is correct, right? Hope you will understand this program. Okay. um, if you have any doubts, please write it in the comments. Okay. um, we will see in the next video with new topics, with new program. Okay. Thank you very much. Bye bye.